Okay, so today I'm just going to go forward with the next lab, number 4 on functions. Is there anything else I need to talk about or answer questions about? Okay. All right, so I don't have my repository. What I'm going to do is clone. I'm going to reclone my repository if I can remember. I think I'm Sam, right? So Sam. Git clone. The network that the Git repository server is on is sometimes very slow, so you may have trouble pushing and pulling. So I'm going to go into my 201 folder, and what you should do, normally you wouldn't do a clone like I just did. Normally you would start your work session like this. The first thing I want to remind everybody to do when you start a work session is to run git pull. And so you can get edits to the files, additions to your repository that Jaren or I may do. Otherwise, you'll have a conflict when you try to push your changes. So the push operation will fail unless you are in sync with the remote repository, which you get in sync with this git pull command. All right, so let's make a folder for lab 4. And I know in advance the problem is going to be a simple one file. We'll have a one file solution to it. So I'm going to go into lab 3 and just copy one of those. Oh, wait a minute. Before I do that, maybe I can sort of judiciously pick one of my previous programs to copy that'll help me solve the given problem more easily. So let's see, this is the lab we're working on, lab 4, this is about functions. So as we work through this problem, I'll talk about what a function is and how to use it and what its purpose is. Let's start by reading the first exercise together. Implement a function that takes an integer value. Now you may not know what a function is yet, so you're going to have to just wait on that before I explain as we go along what that is. But you should be doing the reading, so you should have some notion of what a function is. Implement a function that takes an integer value and returns true if the integer is a prime number and false otherwise. The function should have the following signature. So the function looks like this. A function is a way to modularize your code. So as we've seen up to this point, that a program consists of collections of statements. And generally, one statement executes, the next one then executes, and so on. So it's a linear progression through statements. But then there are something called flow control statements that alter the linear progression. So you may have a loop which repeats a block of statements. The block of statements are executed in a linear fashion, but that block is repeated while the loop condition is true. So that's a slight variation of the linear progression through a program. So we have looping. And then we have branching, and with the if statement. The if statement takes a condition. The condition is true, we do the body of the if statement. Then there's an if-else statement. And so that lets us provide two different alternatives based on whether a given condition is true or false. So those are ways to, the if statement and the loop statements are ways to alter the flow of execution through a program. So we've got these collection of statements that by default execute in a sequential fashion, but we have those flow control statements that can alter that. Now we have functions. Now we're talking about functions. See, the number of statements in a program get very large, and it becomes messy. And so we want a way to sort of break off chunks of logic and isolate them from other chunks of logic, so that it becomes easier to reason about the code that we're writing or the code that we're reading. So a function is the primary means to create a chunk of instructions or logic that we use to separate from other chunks. And then there's other mechanisms we'll look at later, something called classes, which we'll look at soon. So a function, all right, let me stop the lecture right there, and let's look at some practical things now. We solved the problem where we wrote code that determined whether a given number was prime or not. So we want to preserve that's the program that I want to copy. Rather than just starting with a hello program. Let me start with a program that actually has the code in it that determines whether a value, an integer is prime or not. Does anyone remember which exercise of which lab that is?
Lab 3, exercise 1.
Lab 3, exercise 1. Oh, there it is. Look at that. I was just lucky. I'm going to copy that one. And we have test cases already here, so we don't have to redo those. This is the program we wrote already that determines whether a number entered by the user is prime or not prime. That's him down here. So we prompt the user to enter an integer greater than 1, declare the integer, read the integer, and then we declare a Boolean variable called found divisor for n. And we set it to false, meaning that we have an n, but we have not yet determined, we have not yet found a divisor for it. And here is this block of code, we're going to look for a divisor. If we find the divisor, we're going to set our Boolean variable found divisor for n to true. That's a way of us recording that some event happened, that some condition has now been met. And then we come to this other block of logic, which depends on that Boolean variable. So if found divisor for n is true, then we're going to say that n is not prime. Otherwise, we'll say that n is prime. So what we're going to do now is organize this logic. The part of it, there's prompting the user for a value. That's something that we're going to leave in main. But once we get the n, what we want to do is call a block of code that we're going to give the block of code a function. We're going to call a function called IsPrime, right here. We're going to call this function IsPrime. We're going to pass in the value n that we got from the user, and the function's going to return true or false. That's the return type right there. The function will return true or false to let us know whether the n is prime or not prime. And then based on what the function returns, we'll print one or the other response that we have here already. So this is a technique that we'll use to simplify the main program. Actually, look at this. This is a function right here. See this int main, int argc, all that business there. That's called a function signature. Function has this general structure to it. It has It has in C++ anyway, and different languages have different syntax for declaring functions, but a lot of the popular, commonly used languages are practically identical. So a function is something that has a block of statements in it. Here's the block of statements. And when we invoke or execute the function, we are going to execute the block of statements. And when the block of statements execute, we want them to execute with some additional variables passed in. And these are variables. There's two variables here, argc and args. And those two variables provide information that's essential for the function to run. So you'll see, although for our main, we're not using this. We're ignoring these variables. This is information that's passed in, that the operating system passes into our executable, our program. When it's launched as a process, the operating system passes into our process. It gives us, through these arguments to our, this is called the entry point of the program, main. This is where execution starts for our program. The operating system gives us these values. This is how many arguments were on the command line. And this is an array of strings. And each argument that was entered on the command line when we ran the program comes in as a string. But we're not going to, I just wanted to mention that in case you're wondering what this is. We're not going to use that in this course, actually. So the function takes information into this argument list, parameter list, and it executes the functions. It executes the statements that it encloses, and then execution returns from the function. And when we return from the function, normally we have a return statement. Main is a little bit of an exception because the compiler lets us omit the return statement for the main program. I'm sorry, the main function. So that's just the compiler being nice to us. But if we had another function that looked like this that wasn't called main, we would need a return statement, otherwise it wouldn't compile. And this is the return, we're returning the result of the function. So once execution passes through the block of statements that comprise the function, then we want to return a result. And we can return different kinds of results. We can return integers, doubles, strings, and bools, and all different kinds of data types. But each function is declared as returning a specific kind of data type. Here we're declaring that the function main is returning an int. So in our return statement down here, we must return a value that is an int. If we return something else, we'll get an error. I don't think that's going to compile. Let's try it. It worked. Let's return a string. So it was doing, when I did 0.0, it was doing something called automatic data type conversion. So it's converting the floating point value to an integer. But it will not do automatic data type conversion between a string and an int. In other languages it does, like JavaScript will do an automatic type conversion for you. Anyway, that's main, but main is a bit of an exception, so I don't want to talk any more about main, actually. What I want to talk about is that IsPrime function. Now, IsPrime is the name of the function. And we want this business here. We want all of this business to go into this function. Here we want to call IsPrime. So we're going to call IsPrime here to see if the value n is prime or not. And it'll look like this. Just cut to the chase here. That's what it looks like. We call the function IsPrime. We pass in the argument n, the number, and IsPrime will return true if n is prime and false if n is not prime. And so we'll store that in our Boolean variable here. You see how I removed this chunk of code and replaced it by a call to IsPrime. Do you see the simplification now that has happened in main? We've abstracted out, that's the verb that people use. We've abstracted out the details needed to determine whether n is prime or not. And we've replaced those details with a simple function call. It makes this code easier to read. It's shorter. It's more expressive. Reads more like, a technical document. And so now, so these functions get called, you pass in arguments, and they return values, and the values are assigned somewhere or used somewhere within an expression. So you can think of this is an expression where we're invoking the function, and that gets evaluated to its return value. You can use that return value on the right-hand side of an assignment statement. You can use that return value in any place that takes, in our case, a Boolean expression that evaluates to bool. So what about the function? How does that look? Well, IsPrime, when we declare the function, we have to give it an argument list. You know what? I was using this style. You give it an argument list. So the IsPrime takes a parameter n, which is of type int. And the function returns a value of type bool, which is short for Boolean, which means that it's a type that only has two states, true or false. So this is the function declaration, or the function signature. And in here is the function definition. This explains what the function does. Now we need to return true or false. We have to return true or false. We can't return a 0. We can't return a string. So we need to return something that's either true or false because the return type is bool. So, well, found divisor for n is in fact true or false, and that's in fact what we need to return. So it's the same code that we've already had. We just put it somewhere else. We declare the variable found divisor for n, set it to false. We have not yet found a divisor for n. And then we do this loop where we use a variable I. We start with I set to 2, and then we increase I here until I hits n. When I hits n, we don't do the loop anymore. What do we do in the loop? Well, we try to divide n by I. If n mod I is 0, notice that the remainder after dividing n by I is 0, then we found a divisor. So here we return the result. If we go through the loop and for all of I, we never get a 0 remainder, then n doesn't have a divisor in that range. That means we didn't find a divisor, and therefore, because we didn't find a divisor, we know that n is prime. So we return true. On and on. Keep repeating that. So that should do it right there. Well, let's use our test cases. Let's be disciplined. We already have our test cases lined up here. So 2 should be prime. 2 is prime. Let's do the next test case. 3 is prime. Let's do the next test case. 4 is not prime. 4 is not prime. 8 is not prime. 9 is not prime. 27 is not prime. 42 is not prime. 47 is prime. So we passed the tests. And let's see, what else did I ask for in here? Make sure you fully read the instructions. Oh, I want you to use assertions. So we're at use an assert statement inside the function to check the precondition that n is not negative. All right, let's do that. Watch this. How about -2? So we don't want to allow negative numbers. So what we want here is I said to use an assert statement in here that n is bigger than 1. Is that what I wanted? N is not negative. You know what? I'm going to change that. It should be n is larger than 1. Well, maybe wait a minute. Well, I guess we could do it this way. N is not negative. N is not negative. That's that, right? It's not negative. Is it meaningful to ask whether 0 is prime? I think it should be n is positive. Even then, shouldn't it be? Is it meaningful to ask whether 1 is prime? Is that a meaningful question? Any math majors who want to answer that? Yeah. Is that a meaningful question? Not meaningful, right? Not meaningful. It's like, is the color red even? That's not a meaningful question, right? So is 1 prime? That's not a meaningful question. So I'm going to change that to n greater than 1. And I'll fix the instructions. Oh. Everybody see what's going on? You'll be getting this more often than I get it, right? Assert is undeclared. Oh, so it's some include statement. I think that's what it is.
You have it on
Is it C assert or assert? C assert. Up. Took the wrong picture. It's hard to keep up. I am recording this, so all these lectures are recorded. I don't know if everybody knows that. So let's see that. That works. Now let's try what we just did. I put in -2. Assertion failed. Okay, that's what we want. We're going to start using assertions now. An assertion is a function that takes an argument that's true or false. If the argument is false, assert shuts down the program and says your assertion has failed. Because I'm asserting something. I'm asserting that n is greater than 1. Well, if that's false, something's wrong. We're not going to carry on with anything else. We're just going to shut down at this point and report a failed assertion. So this is one way to catch errors. You don't use this when you write code for like an end user application. This is for development purposes. All right, and then let's put in these assertions in here. So in main, instead of this business, instead of this, we're just going to test our function like as follows. IsPrime 2 is false, right? And let's do this. Now we're writing test code here. All tests pass. So an assertion only complains when something is wrong. So IsPrime 3, that should be true, right? So here's our test code is faulty. So assert, oh, what happened? IsPrime 3 is false, right? Should be true. What's wrong with that? Oh, I didn't compile it. This better fail. What's going on? Why is that true? Why is that false? What am I doing wrong? Anybody see that mistake? So IsPrime 3 should be true. Why is that failing? Oh, I don't get it. Oh, this should be false, right? Oh, there we go. I don't know, what was I doing wrong? I get it on video, so I'll go back and look at it. So this is a wrong test case. This should be true. IsPrime 3 should return true. IsPrime 4 returns false. What's the next test? 8? A 5? And what's the next one after 5? 8? And then we did 9. And then we did, was it 27? And then we did 42. And then we did, was it 47? Yeah, 47. There we go. So we did our original test cases. We don't need this anymore. We don't need that extra stuff to read. We have our, this is readable enough. But we need to get these right. So this is false. This is true. This is false. This is true. This is false. False, 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 and true. And so, do you see what we're doing here? This is automated testing. And this is very important. Oh, I did something wrong. Is prime true? It's the same problem. I don't get it. How could that be? Why would that come up like that? It seems random. So n is 3. I'm really lost here. What's going on? I know it's something obvious. So does anyone see the problem? What's going on there?
It divides 3 by 2. It doesn't go any higher.
We divide 3 by 2. 3 by 2, and it's, oh! Ay, ay, ay. Now I see the problem. That's dumb. Oh, no, I don't see the problem. All right, let's read it. So when n comes in as 3, this assertion is okay. We set this to false. We set I to 2. I is less than 3. Then n divided by 2 gives a remainder of 1. That does not equal 0. So found divisor is false. And then we increment I. I becomes 3. The loop condition is false. So we return found divisor for n, which is false. Oh. This should be, if we found a divisor for n, it's not prime, right? So it should be, let me get it backwards. I'm really lost today. Is that right? If we found a divisor for n, if we didn't find a divisor for n, found divisor for n is false, that means n is prime. But why is 2 is prime 2 is false? Why is that coming up true now? Found divisor for n. Huh?
2 is a prime number.
Oh, it is prime. Oh yeah, it is prime. What am I? I'm not even. My brain is gone today. Thank you. I need more participation because I can't solve this problem I've been using for the last 5 years. All right. That's false. That's true. 2 is prime. Thank you for saying that. Check that. That's prime. That's not prime, not prime, not prime, not prime, prime. All right. Anybody willing to make a bet? All right, I'm ready to make a bet. I would have won the bet. So we had the test code wrong right here. We said that 2 was not prime. And that really screwed us up, right? We had bad test code. We had to debug the test code. Now, this isn't how I would write it. I would write it differently. I would put it like this. Oops. Two is not prime. 3 is prime. 4 is not prime. 5 is prime. 8 is not prime. 9 is not prime. 27 is not prime. 42 is not prime. What's that?
Isn't 2 prime?
I made the same mistake. I really failed this quiz. Okay. Did I get it? All right, there it is. Any questions? All right, so a lot of the problems now will look like that with assertions. All right, listing prime numbers of functions. Let's get to this. In a previous lab, we wrote an application that displays all the prime numbers between 2 and a number entered by the user. Write a program that has the same inputs and outputs as the previous exercise, but this time use the IsPrime function you developed in the previous problem to simplify your code. Specifically, replace the inner loop by a call to IsPrime so that your new program uses a single loop inside the main function rather than a loop nested within another loop. So what we're going to do here is improve the readability of a program that we wrote for Lab 3. Let's look at that. Was that number 2? Okay. All right, let's remember this. So we asked the user to enter in a number, and then we printed out all of the prime numbers up to that number. Let's see it run. So 9, we print all the prime numbers up to the number entered by the user. Let's improve the readability of this program. For the VI users, you can take a look at what I'm doing there. I'm using that E. So I'm going to edit another file. And I'm going to copy. I'm going to go into this visual mode, hit Y to yank. I'm going to use E# to bounce back to the last file, and then I'll paste there. So now we have this, we've tested this function. So hopefully we're confident that it's correct. So now what we're going to do here is replace this code here, which determines whether n is prime or not, with a call to IsPrime. If IsPrime, no, I'm doing it the wrong way, isn't it? So if I is prime, I'm sorry, it's n, isn't it? There's an n there. If n is prime, then print it. That's it. We read a value k, and we declare a variable n and have it range from 2 to k. And for every value that we hit that's prime, we print that value. Nope. What's the problem?
We didn't include these things.
Need to include that. Nine. Works the same. Good. That one wasn't as challenging for me as the other one. Do you see what we've done here? Look at the new main. Look at how much easier that is to read. Get a value from the user. Create a loop that goes from 2 up to that number, pass the number to the IsPrime function, and print it if IsPrime tells us it's prime. And then we've removed the details of determining whether n is prime or not. We've put them somewhere else. And this is the key to building larger programs. You need to modularize activities. And using functions is the primary way to do it. And then there's other ways, as programs get even bigger, there's other mechanisms. You have namespaces, you've got classes, and you've got systems which are distributed. They're not even running on the same computer. They talk to each other through interfaces, and because they're so big, you want to break them into pieces. So as things get bigger and bigger, you always have to manage your pieces. You have to decide how to section off activities and keep them separate and distinct from other activities. All right. Let's do the last one. Listing random colors with functions. Reorganize your code in your solution to the listing random colors problem of the previous lab so that generation of a random color string is performed in a function. Use functions to remove any nested loops, loops within loops that are in your code. All right, so this is not, does anybody remember where that came from? Is that exercise 3?
That was 4.
Huh?
That was exercise
4? It was 4. So here is the code that we wrote last time to print out 100 random color values. Let's see how that works. There it is. 100 random color values. And one of the things that makes this program hard to read is that there's a nested loop. There's a loop within a loop. So let's get rid of the nested loop. Let's do this. Let's create a function that doesn't return a value. It just does something for us. Oh, wait a minute. Maybe it should return something. let's have it return a string, I guess. I'll say a random color. So we want to get a random color. So get random color. And that returns a string. This is where we, I'll use this, I'm going to try this thing here. Oops. That's it right there. We just call get random color. It returns a random color string. We print it, and then we're done. That looks pretty easy, right? It's easy to read. And let's do this incrementally. Let's not try to get everything done at one go. So I'm going to comment out. You see that multi-line comment? I'm going to comment out this block here. Because it's a little bit messy right now. The indentation is wrong, and I don't know what's going on in there yet. I forgot what it does. And instead, we will just return a string. Say, FF00 AA. Here's a random color string. So you should get 100 of those. There we go. So we got the function working, the function call, we've got our main code nicely simplified. Let's go ahead and figure out what to do down here. So let's build the string now. So I have a string called say color. Start with an empty string. I can see I need to shift everything over. Just do that real quick. And so what we'll do is append onto that string here this is color plus equals n. I think we can do that. I gotta make sure that works. So we have a color, it's initially empty string, and then we're going to append n onto it. So there's a conversion there because n is an integer. So we append an integer onto a string. Can we do that? That would have to be an instance of automatic data type conversion, wouldn't it? And I work in so many different languages, I can't remember whether this language, C++, allows that automatic data type conversion from int to string. Let's see if that works. These others look similar. This would be the A. Someone mentioned the other day that we could have used the character A rather than the string A. It's a little more efficient, maybe, probably. And I'll talk about the difference in a moment. All right, this is an F. This is an E. This is a D. This is a C. This is a B. Is that going to work? So we declare a string here. Oh, I can see it's not going to work. We're not returning anything. We got to return this string. There we go. So we declare the color string here. It's empty in the beginning. And then we go into a loop that runs exactly 6 times. And inside the loop, we're going to append a hexadecimal digit onto the string. It's going to start as empty, but we're going to do 6 append operations. So we'll end up with 6 hexadecimal digits. Does that look okay? This is the part where I'm not sure if that's going to work. That's the automatic data conversion. How about we do it like this? Let's test the part that we think let's test the part we think that will work. We'll put a question mark there, and then we'll fix that. Now, it seems to be pretty good. Let's see if this works now. Oh, compiler liked it. That's a good sign. That doesn't look very good. This isn't going to work. How do you convert from an integer to a string in C++? Anybody have the book? You look it up. How do you convert int to strings? Look under string and index or the. This is the old-fashioned way to do it, right? Use the book. And wouldn't you just use Google? Okay. Yeah, fine. We're supposed to practice the old-fashioned way. This is amazing. I could type this in here. Let's see what happens here. Bam. Use that function? Oh, this is complicated. Very inconvenient. It's too bad we're not working in a friendlier language, you know, like JavaScript or C# or something like that, because we wouldn't have to do this. This is an old library that is a part of C, I think. And this is the new way to do it, which is really kind of important but hard to understand. We can use this. Another way to do it. Oh, what is this? Hey. Oh, this is the newer version of C++. This is much easier. Just this. And why are they using 42 all the time? Do you guys know 42? That's the answer to the ultimate question. You guys know that? That's why you always see 42 all the time. So, let's try that. So is it as simple as that? Look at what it has here. It has std : : How come I omitted that? Also, it's 2 underscore string. Let me fix that first. Why did I omit STD colon colon? Anybody know?
Because you're using namespace.
Exactly. This statement here says, hey, everything that's in the STD namespace, merge it in with my namespace. So all the symbols that are defined under STD become symbols that I can refer to directly. And it's dangerous. Some programmers will never do that because it's too big of a namespace, and so it's likely to create name collisions. So that's a bit dangerous, but that's the way we're doing it, and we're living dangerously. But this is part of the new C++ language. Does my compiler support it? Because when you go to the labs upstairs, this might not work. So you got to do it the hard way. Let's see. That's a good sign. It works. I can't believe it. Well, you know, if this doesn't work for you, then one thing you could do is list everything out like this. Just have, you know, the 0 through 9 digits and have an else if clause for each one of those digits. That's one way to do it. I think I did it that way last year. Another way to do it is to use this integer to alpha function that's inherited from ancient days. Or you could use this string stream class, which is part of the C++ standard library, but you need to restructure a lot of the code, and you use what's called a string stream object here, and they're very handy and useful. So we could look at that if we have time, this particular solution. So if this doesn't work in lab today, what I'd like to do is show you in lab how to use this string stream class here, because this carries over into other language contexts, and it's sort of the normal way that you would do it. We did everything, almost. What didn't we do? We did not put things in the repository yet. Please remember to do this. And we should have done this after each one. Oops, that was crazy. You know what? Just to play it safe, I'm going to do git pull, so just in case Jaren added something to my repository. And now I'm going to push it. This push operation is fast right there, but it has been very slow the last day and a half. So be patient with it. And if your pushes don't get through, your pulls don't come through, then try later. All right, that's it.